This is Unit 5 of the course Basic Mathematics, and it's about ratio, rate, and proportion. Objective number 1. Define ratio or rate and convert a given ratio or rate in fraction. A ratio is quotient of two quantities with the same unit. Example number 1. The ratio of 3 and 4 can be written as 3:4, 3:4, or 3/4, or 3/4. Rate is a comparison of two quantities with different units. Example number 2. 80 kilometers in 1 hour can be written as 80 kilometers over 1 hour, or 80 kilometer per hour. Notice here that the units are not cancelled out. Example number 3. Express the ratio 200 cm is to 15 m in simplest fractional form. So we know that 100 cm equals 1 m. So that means 200 cm equals 2 m. We can write it as 2m over 15m. Since the units are the same, we can cancel out m. So our answer is 2/15. Example number 4. Ziad types 124 words in 4 minutes. Express the rate in simplest fractional form. So this is our solution. 124 words over 4 minutes. 124 divided by 4, that's 31. So that's 31 words per minute. So the units are not cancelled out. Objective number 2. Express ratio or rate in lowest terms. Example number 5. Express 32m is to 80m in lowest fractional form. So this is our solution. 32m over 80m. And we can divide both the numerator and the denominator by 16m, which is the greatest common factor. So 32m divided by 16m is 2, and 80m divided by 16m is 5. So our final answer is 2/5. Objective number 3. Define proportions and identify its parts. So proportion is the equality of two ratios. Example number 6. In the proportion 4:5 and 12:15, what are the means and what are the extremes? So we have here 4:5 equals 12:15. So 5 and 12 are called the means, while 4 and 15 are called the extremes. Objective number 4. Determine whether two ratios are proportional or not. Example number 7. Are 7:28 and 1:4 proportional? For our solution, we are going to multiply the means, and we will also multiply the extremes. So 28 times 1 equals 28, and then 7 times 4 is also 28. So the product of the means equals the product of the extremes, so this means the two ratios are proportional. Example number 8. Are 12/15 and 3/5 proportional? Again, we will also multiply the means, and we will also multiply the extremes. So for the means, we have 15 times 3, that's 45. For the extremes, that's 12 times 5, that's 60. The product of the means is not equal to the product of the extremes. Therefore, the two ratios are not proportional. Objective number 5. Find the missing term in a proportion. Example number 9. Solve for x in 4:7 equals 20:x. So we are going to multiply the means and we will also multiply the extremes. So 4 times x is 4x, and then 7 times 20 is 140. Now dividing both sides by 4, x equals 35. Example number 10. Solve for x. 48/72 equals 8/x. So here we are also going to multiply the means and we will also multiply the extremes. So 48 times x, and we will also multiply 72 times 8. 48 times x equals 48x. 72 times 8 is 576. Dividing both sides by 48, x equals 12. Objective number 6. Define and illustrate the direct and inverse constant of proportionality. So, if our statement is y varies directly as x, our equation is y equals kx, or this symbol, where k is the constant of proportionality. Example number 11. Y varies directly as x, and y equals 30 when x equals 6. What is the constant of proportionality? Our equation is y equals kx, and y is 30 when x is 6. So that means 30 equals k times 6. So to solve for k, we are going to divide both sides by 6. And 30 divided by 6 is 5. So this is our answer. If our statement is y varies inversely as x, this is our equation, y equals k divided by x, or this symbol, where k is the constant of proportionality. Example number 12. Y varies inversely as x, and y equals 12 when x equals 3. What is the constant of proportionality? So our equation here is y varies inversely as x, so that's y equals k divided by x, and our y here is 12 when x is 3, so it's 12 equals k divided by 3. To solve for k, we are going to multiply both sides by 3, so 12 times 3 equals 36. So this is our answer. Objective number 7. Define direct variation and solve word problems involving direct variation. Example number 13. If y varies directly as x and y equals 12 when x equals 3, find y when x equals 9. So our equation is y equals k times x. So that's y varies directly as x. Now y is 12 when x is 3. So that's 12 equals k times 3. To solve for k, we are going to divide both sides by 3. So 12 divided by 3, that's 4. Now going back to our original equation, so that's y equals 4, the value of k, times 9, which is the value of x. So 4 times 9 is 36. So this is our answer. Example number 14. The distance traveled by a car in a given time is directly proportional to its speed. If a car travels 120 miles at 80 miles per hour, how far will it travel if its speed is 60 miles per hour? Let d be the distance traveled and s be its speed. Our equation here is d equals k times s. That's the distance traveled is directly proportional to its speed. Now, the distance traveled here is 120 and our speed here is 80, so that's 120 equals k times 80, dividing both sides by 80, so 120 divided by 80, that's 1.5. So k here equals 1.5. Now going back to our original equation, d equals k times s. Our k is 1.5 and our s is 60, so that's d equals 1.5 times 60. And 1.5 times 60 equals 90. So our answer is 90 miles. Objective number 8. Define inverse proportion and solve word problems involving inverse proportion. Example number 15. If y varies inversely as x and y equals 25 when x equals 8, find y when x equals 40. So our equation here is y equals k over x because it's y varies inversely as x. To solve for k, we can multiply y and x. So that's k equals x times y, and our x here is 8 and our y is 25, so 8 times 25 equals 200. So this is our k. Now we are going to find y when x is 40. So going back to our original equation, so we have y equals 200, that's the value of k, and then over 40, this is the value of x, and 200 divided by 40 is 5. So this is our answer. Example number 16. The time required to finish painting a room varies inversely as the number of people doing the job. If it takes 5 hours for 9 people to finish the job, how long will it take to finish the same job if 6 more people are added? So first, let t be the time required to do the job, and n be the number of people doing the job. So our equation is t equals k over n. So our t here is 5 hours and our n here is 9 people. So that means 5 equals k over 9. To solve for k, we are going to multiply 5 and 9. So k equals 45. Now going back to our original equation, so t equals k over n. So our k is 45. And then we are adding 6 more people, so that means we have t equals 45 over 15. So why 15? Because originally there were 9 people and 6 more people are added, so all in all there are 15 people doing the job. So 45 divided by 15, that's 3. So our answer is 3 hours. Thanks for watching, guys. This is Teacher Rejil. Keep safe.